Weather radar is how meteorologists see things like raindrops, snowflakes, hail, graupel, and even objects like birds, bugs, and debris being kicked up by storms. Radar does this by sending out a radio signal that detects those objects and how fast they're traveling towards or away from the radar site, much like police radar does when it's catching someone speeding. Hold that thought. The radar scans the atmosphere at different angles, starting at half a degree. Some radars scan even lower than that so they can see further, then tilts up until it doesn't see precipitation anymore, or the radar can't tilt higher. This is known as a volume scan. The radar produces several products, but the most useful ones are reflectivity and velocity. Reflectivity tells us how reflective an object that the radar signal hits is. The more reflective it is, like heavy rain or hail, the further to the red and purple end of the color scale it shows up as. Composite reflectivity shows the greatest reflectivity over a spot in the volume scan. Velocity shows us how fast objects are moving towards or away from the radar, just like that police radar we talked about, except the police radar is checking out cars and trucks. If an area of raindrops that are moving really quick towards the radar are right next to an area where they're moving really quick away from the radar, it's got our attention because the storm is rotating and has the ability to produce a tornado. The radar produces other products which give us more detail as to hail size and if a tornado is doing damage, which helps us issue better warnings and more detailed warnings. For the National Weather Service in Glasgow, Montana, I'm meteorologist Mark Avery.